I think reality is what really has happened is that's why I love my crystal ball, is because you try to look into the future and you try to figure out how to prevent things from happening. So for me, it's always looking backward on existing jobs that I've done and the failures of other people that have done a lot of things. And I came up with a thing I called it the 7 deadly sins of lighting. So there's a lot of things as being an electrical contractor that I would have to do, so I would never have to go back, right? Because going back to a job obviously costs a tremendous amount of money, and then I don't get future work or future consideration from my future generals. So there was a lot of things that I had to do correctly. So bringing that thought process into the low voltage lighting, I thought there were 7 serious categories. So the 7 deadly sins of outdoor lighting. So the first one for me was corrosion and wicking. The second one really was moisture migration. I think the third one is corrosive materials. Glare is a huge thing for me. Lighting designs and the lack of training, and then of course future considerations. So I think those 7 things summed up everything that I tried to do. And future considerations for me really, it could almost be the umbrella that everything else goes under, because when you think about future considerations, it's wicking, it's corrosion, it's the breakdown of material. So I like to use material that's made for a lifetime. I like to use some type of a dielectric grease in every single connection. So like one of the things in our transformers, and I don't even think that we say this loud enough and beat our own drum, if you will, is we put every connection on the inside of our transformer has dielectric grease, a silicone-based dielectric grease. So when that transformer is sitting on some house next to the ocean, and that salt air goes in through the louvers and the gaps of the transformers, it won't ruin the connection. It's the connection. Whether it's inside a transformer, it's inside a hub, it's inside a fixture, it's the connection. So those 7 things are really the crux of how I built all my things around. On the mechanical side, the electrical side, yeah, we prevent connections. On the other side of it is, material, solution-based, like, picking the right material so it lasts for a lifetime. When I, as a homeowner, I guess my best analogy is, I look at warranties when I go purchase something. So what's the warranty, right? Is it 1 year? Is it 5 years? Is it 10 years? Is it lifetime? So I look at I go buy a TV and it's got a 1-year warranty. I look at that as a death certificate in advance. It's dying in 1 year, right? So warranties have a huge play for me when I purchase my product. And then if I look at, what's the stability of the company? And right now, there's good reasons why you sell to a $2.5 billion company. They're not going anywhere, right? They're going to be here tomorrow. You don't want to sell your company to a company that's worth $100, right? If you know what I'm saying. So when the warranty, you look at the product, brass or copper, it ain't going anywhere, right? So warranty's huge for me, but you gotta back up the warranty with good material. I think the fairest way for me to answer that, everything has a purpose. So you're on a job and you buy the best fixtures you can, the best warranty, the best sockets, the best light bulbs. And what really cracks me up, and I think it's really hilarious, is the contractor will now go out and buy the cheapest wire known to mankind. They view that as a commodity. Well, Unique, most people don't know this, Unique makes their own wire. And is it more expensive? Of course it's more expensive. People don't realize that this is getting back to what we talked about earlier about, the heart of the system, it's step 1, step 2, step 3. So I got to get the electricity from the transformer to the hub, from the hub to the fixtures. If I use the cheapest wire I can buy, what happens is electricity travels around the wire. So cheap wire is not, like Unique, I guess I'll step back for a second. So Unique, there's 2 main things in the wire. We use 99.9% copper, and it's 100% virgin plastic. The reason you want 99% copper is because the flow of the electricity around the wire doesn't want to be impeded, if you will, right? Like, there's companies out there that might use a tinned wire. Well, tin is a bad conductor, so you lose about 7/10 of a volt because it's a bad conductor. So we always want the electricity to flow fast. Second thing is we want to use 100% virgin plastic. So when you look at the wire 5 years in the ground, a lot of times you pull the wire up, it's stiff as a board. And that wire's cracked. And well, of course, if it's cracked, it prevents wicking. Now it's all black. So getting back to the contractors buying the cheapest wire, they're wanting to put a lifetime guaranteed system in, but they're putting the cheapest wire in. The wire's going to fail. It's going to fail at the connection. So good wire is important. So even our wire has sense and purpose. Even our wire is solution-based. And again, I used the cheapest wire I could possibly find too in the beginning, until I went back to the jobs years down the road and found out that my lighting systems were dim and weak and they weren't performing because it was the wire.
The wire is the cheapest part of the project.
What? Today with LEDs, we're talking maybe it's $20 more to go with the best wire. You know, so, you know, and of course you got to make your distributors bring the best wire in, because the best wire is just not sitting on the shelf. So when we're fusing the hub system now, we've always fused per load. We've always taught at our training seminars by an amp probe, right? And you know, we'll have a technical tips and tricks video later on the amp probe, so hopefully everybody will go to it. But now when we use the amp probe, we can get the amperage of the system. So maybe you have 10 LED lamps. Well, you're using, what are you using? 4 watt, 5 watt? So you got a 40 watt, 50 watt load, right? You're talking, you know, 3 or 4 amps. So when you have 3 or 4 amps, it's not a big load. So if you generate a short though, via the gardener, or something shorts out in the LED, somebody does a bad connection, it's only gonna be a 20 amp, you know, 15, 20 amp draw. Versus a halogen, it would be way more. So having a 5 amp fuse now, or a 10 amp fuse at the hub, that fuse will blow now and protect those LEDs, protect that wire. I mean, who wants, how much is an LED? 30, 40, $50? I don't even know, right? Versus a $2 halogen lamp, you want to protect everything. So fusing now is more relevant and more important today because of the lack of load, versus when halogen, it would be a huge load and it would blow the fuse of the transformer. I view things like this, and I think one of the things that I've been able to achieve, what I've achieved, I believe everybody's a liar. I don't believe anybody. So I have my own illuminated layer, if you will, Rusty, right? I go test my own things. I use my own meters. So I make sure when somebody says something, or if I don't really know anything, right, I do my own testing. And from what our own testing we have found out, and engineers too, we've got some, I still obviously have a lot of assets around. You know, we found out that, you know, the LEDs are designed at 12 volts. Will they work at 10? Will they work at 11? Will they work at 12? Will they work at 13? Of course they will, but they don't perform as well. So I equate it to an automobile engine, right? So if we all had the same engine, and I ran my engine at 2200 RPM, and you ran yours at 5000 RPM, my engine's just gonna last longer. And I think that's a good analogy. You know, I have a boat. Boat engines typically last 200 to 400 hours. Why? Because everybody's ramming them up at 4,000, 5,000 RPM. Well, I run my boat engine at about 3,600 RPM, and it's going to last a lot longer. So will they work? Yes. How well they perform, how well they'll last, nobody really knows for sure. So for my advice to people is, you know, you're putting in a product that can get you 20, 30 years of life. Let's get 12 volts to them and give them a chance to do that. We've been messing around with LEDs for about 7 years, and I'm going to say, so the last couple years they've came into play now, right? We've gone from the drop-in, which obviously we were instrumental in, unique was, I think, versus integrated LEDs. I still don't believe in integrated LEDs because if and when the light bulb does fail, you're throwing the whole fixture away. So I believe drop-in replacement is the way to go. I believe that they'll keep coming down in price, which is good news for us as a consumer down the road. So if we don't really get our 20 years out of them, we got 15 or 12 years out of them, well, they're going to be a lot cheaper in 12 years. The color now is fantastic. The consistency of, and when I say that, there's a broad spectrum of cheap to expensive LEDs out there. The cheap LEDs don't work. The cheap LEDs are completely opposite of the good LEDs. So, you know, when you look at good LEDs, what I like to do is I like to take 5 LED lamps, I like to put them on a white wall, and I like to look at the color. Is the color consistent between the beam spreads? Are the beam spreads consistent, right? And we're getting that now. So I'm very pleased with them. And one of the things I think we find out now, which I'll tell you now, I believe our Starburst fixture is the best fixture to use now because of the LEDs. In the old days when we had halogens, they were really beam orientated. You'd pick out a 35 watt or 35 degree, 36 degree, and that beam would be very specific, very pattern orientated. Now with the LEDs, they're 180 degree based fundamentally, even though they say they're 35 degree. they still emit light more in a 180-degree pattern. So when they're in some type of a tight bullet light, it kind of helps constrict the light, where like in our Starburst wall washer, it allows that light to emit more freely, if you will. So the LEDs I'm finding out are more conducive to landscape lighting than the halogens because of the beam spreads are more friendly. There were about hundreds of choices on the MR16s between wattages and beam spreads. We dumbed it down and said, listen, you need a 20, you need a 35, and then we would give them lenses, right, to help, you know, diminish the light or move the light or orientate the beam spread differently with spread lenses and linear spread lenses. Well, the same thing now is happening with the LEDs. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, whatever, tons of choices on LEDs. And I think we can dumb it down too. I think myself, I think you just pick one. The 4 is unbelievable. It's unbelievable what it does. So what's the difference between a 4 and a 5? It got me, right? Pick one, either one. I don't even care. What's the difference between a 1 to 4 and a 4 and a 5? Nothing, right? I've been using a lot of the 4s and I'm happy with them. You can give me any lamp and I'm going to be happy with it. I can make a 4 lamp work as well as I can make a 5 lamp. So I think you pick a 4 or 5 and then you pick your 8, right? And then you pick your 1 or 2 for your G3s, right? And you can do anything with probably 3 or 4 lamps. I had lunch the other day with a contractor and we were talking about retrofitting and going back, and he was reinforcing the hub method to me because, you know, systems that he was putting in that we trained him 12 years ago on, he's going back now 12 years later and the system is still perfect. So he's able to go back with confidence, go back to those homeowners and effectively do, you know, a quick engineering study, if you will, right? Evaluation about what the potential costs are to retrofit for LED and the payback. You know, and he was, you know, 4 to 5 hours to relamp all the fixtures, and you know, it's within, you know, a couple year payback. It's pretty fast. So the key is you got an 840 watt transformer on the job, and it used to pull, which we know is a 7 amp fuse, or an 8 amp fuse in it, but you know, maximum draw of 7 amps. Now you're going to put an LED system in, and it's probably only going to draw 1 amp. So what you really need to do is you need to put a 2 or 3 amp fuse in that transformer now, so you're protecting everything. Unique, I believe, is the only transformer that has a replaceable fuse in the transformer, where nobody else does that. And we want to be able to protect everything in the transformer via the fuse, and I want to protect everything downstream on the home run, the cabling, and everything on the infrastructure, and the primary fuse will do that. So you get to your amp probe, you find out what your new amperage is, and yes, you amp per load. But it is interesting how you mentioned that. There's a lot of misconception out there that people think you have an 800 watt or 1,000 watt transformer. It pulls 800 watts or 1,000 watts. It doesn't do that. It pulls whatever the load is.